Okay, so this is your sheet that you got today. Okay, and it has same questions as the stations, but obviously numbers change a little bit. So, excuse me. So the first one, she has 4 batches of brownies. Very important for you to understand the question. Okay, so that you can actually draw it or even write the number sentence. 4 batches of brownies that she wants to split up for the class. Each person gets 2/3 of the brownie plate. How many people could Jessica give brownies to? So 4 batches. So think of it as 4 trays full of brownies. 2, 3, 4. I don't know why I did circles. So that's a plate full of brownies. That's another plate full of brownies. I'm going to cut them into thirds, or ugly thirds. And you want to divide it by 2/3. So, and again, here, 2/3. So I represented the 4 batches of brownies. You have 1 batch, 2 batches, 3 batches, 4 batches of brownies, and 4 divided by 2/3. How many times can these 2/3? So every person in that classroom gets this much, 2/3. So how many people can we give this to? Well, here's 1 person. If I take this third with this third, that's 2 people. These 2 right here, that would be 3 people. These 2, 4 people. This one at the bottom with this one at the bottom as well will be 5 people. And 6 people. So in total, if I get these 4 batches and divide them into 2/3, everybody getting 2/3, I can share that with 6 people in the classroom. Okay? They come out a little bit ugly, but I think you get the point. Let's clear everything. Larry has 3/5 of a chocolate bar, so Larry has 3/5 of chocolate. So draw it out as you read it, so you can understand what you have. 3/5 of a chocolate bar. 1, 2, 3, 4, 5. So this is how much you have right now. 3/5. 4 of his friends come over and say, we want you to share what you have. So how are we going to split the 3 that we have, the 3 little pieces that we have among 4 people? So why don't we cut each of them into 4 pieces? 1, 2, 3, 4. Or in essence, we'll just make this, just make that line go all the way across. So cut everything into 4s. So each of the original bar that I had, I cut into 1, 2, 3, 4 pieces. This one, 1, 2, 3, 4, and the last one into 4 pieces. 4 friends. So if I have 4 friends, first friend, let me change colors here, will get this one, and this one, 3 pieces. So friend number 1, friend number 2 will get this one, and this one. Friend number 3, this one, and this one. And friend number 4 will get the last 3 pieces at the bottom. They each get an equal amount. What did I forget to do? I forgot to extend this line here. Okay. So, first friend will get this much. How many will he get? He will get those 3 pieces. So he's going to get 3 pieces out of a total of 1, 2, 3, 4, 1, 2, 3, 4, 5 out of 20. So each friend walks out of there with 3 out of 20 pieces. And the sentence here was 3/4 is what you have. I'm sorry, 3/5. Okay, 3/5. And you're going to divide this by, you're dividing this among 4 of your friends. And your answer is that every friend gets 3 out of 20. Okay? 3. This problem gave you a few problems today. Luz is building tables out of wood. So you go to Home Depot and you buy wood. So imagine this big plank over here. And how many are we buying? We're buying 9. So 1, 2, 3. And I guess you're someone who builds tables. So you need wood to build tables. So 3, 6. You buy these 9 big pieces of wood. You take them home into your shop and you want to make tables out of them. One thing we know is that to make a table, you don't need the whole table, but you do. I'm sorry, you don't need the whole piece of wood, but you need 3/5. So 1, 2, 3, 4, 5. To make one table, this is how much is required. 3/5. Okay, so how many tables can I make this? Can I make out of all these 9 huge pieces of wood? So if you wanted to model this, you would cut everything into fifths. Okay, and you would count threes, 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 and the number of times you can make groups of threes would be the number of tables you can make. So in this case, it doesn't ask us to model, but so we're going to take 9 pieces of wood that we bought at Home Depot. We're going to divide that by 3/5 because we want to cut them in 3/5, side 3/5. LCM, I'm sorry, put it over 1. And the LCM is 5, or LCD. That 5 stays. This one was times 9, so the top is times 9. We got 81. Okay, so remember, if the denominator is the same, you can literally cancel these out because they're the same size. So how many times can 3 go into 81? Let's write it as a fraction first, so 81 over 3. And that would be 27. So you can make 27 pieces of 27 tables with 9. So with 9 tables, sorry, let me take that back. That was 9 tables. 9 pieces of wood. 9 pieces of wood, or I'll just write 9 wood, you can make 27 tables. Okay. So you want to know how many it would take to make 45 tables. So, that gets a little complicated. We know that 9 pieces of wood, you make 27 tables. Let's see if we can simplify this, or we can even say that with 3 pieces of wood, okay, you can make 9 tables. Okay, so if with 9 I can make 27, that also means that with 3 I can make 9. Okay, a little proportion here. All right, so if I know this particular what do you call ratio here, I can find, so to 9 I would need 15 pieces of wood. Okay, hopefully you see the relationship. From 9 to 45 is times 5, so 3 to this mystery number would be times 5. 9, how did I get to 45? It would be times 5. 9 times 5 gives me 45, and 3 times 5 gives me 15. So there's a relationship I was looking for. A little bit harder. I didn't mean to meet that. I should have made the 45 more accessible to you guys. So I didn't mean to make it 45. I should have maybe made 54, something a little bit simpler. But if you did get it, okay, good job. Clear annotations. How many 2/10 are in 8/10? Show your work using your model, please. Okay, be aware that how many 2/10 are in 8/10 is not written like this. Okay, that says how many 8/10 are in 2/10, so it's definitely backwards. So you're gonna write 8/10 divided by that. Okay, so definitely this is not the right answer. Very simple. Wow, that's an ugly 8, but it's okay. So did we ask for a model? Yes, we did. So you're gonna take something 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you want to shade 8 of it because that's what we have. So 8 goes all the way up to here. I'm going to take a rectangle and break it up in 10 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going to only shade 2. Notice that the pieces are all cut up in the same pieces. So this 2, okay. These are all 1/10, 1/10, 1/10. They're all the same size. So how many times can these 2 pieces right here fit inside? Well, it can fit here and here once, so that's 1 time. You can fit the 2/10 here again, the 2nd time, a 3rd time, and a 4th time. So 8 over 10 divided by 2 over 10 is just simply 4. So that's with the model, but if you think about what we did in class, by ignoring the denominators because the size are the same, this just becomes 8 divided by 2, which is indeed 4. Where are we? How many 4/5 are in 14 over 15th? Well, same type, clear notation. And the sentence would be 14 over 5 divided, I shouldn't take 5s anymore, and over 4 over 5. These are fifths we're talking about, so let's draw something that's 5. 1, 2, 3, 4, 5, and we're going to need a little bit more because there's 14 of them. 14 over 5 means what? It means 14 1/5. You gotta shade 14 1/5. These are all 1/5. 1/5, 1/5, 1/5, 1/5, 1/5. And we need 14 of them. Well, there's 5 over here. 6, 7, 8, 9, 10 over 5th. 11, 12, 13, 14 1/5. There. That's the first representation. Second one, you take that same bar, 1, 2, 3, 4, 5, and we're going to shade 4. Okay, and now you're asking yourself, how many times can these group of 4 fit in here? Well, let's see, if it's 1 time, if it's 2 times, if it's 3 times, so 3 times for sure. And then you're going to take these 4 and try to fit in these 2. It won't fit all of them, but it will fit 2 of them. Right? These 2, this one and this one can fit here and here. So 2 out of the, how many you're trying? Out of the 4. Or you simplify 3.5. Okay, if you take this and if you do it without the modeling and you actually had it without the modeling, what would you have done? You would have ignored the denominators because they're the same, and you would have written 14 over 4 like that as a fraction. 4 goes into 14 3 times, 2 left over, 2/4, and simplified 3.5. Same thing. Alright, next one. 7. A huge batch of cookies required 1 2/5 cups of sugar. How many batches can Sam make with 12 1/4? So you have, this is how much you have. And you want to break it up into 1 2/5 parts because you want to make batches of cookies. So this right here is 1 batch of cookies. You have a lot of sugar, so there's definitely more than 1 batch that you can make. It's a mixed number. Change it. Okay, 49 over 4. 4 times 12 is 48 plus 1. Same thing here, times and plus. And you get 5. 5 times 1 is 5, plus 2 is 7/5. LCM between 4 and 5 is 20. Oops, 20. This was times 5, and this was times 5. 5 times 9 is 45. Carry the 4. 20, 24. 5 times 4, and that's 4, so that's 28. So this is going to be, if you throw this out as a fraction, you get 245 over 28. And 28 goes into 245, God knows how many times. 10, no, a little bit, 10, 10, no, definitely not 10, maybe 8, 8 and something. Alright, I'm not going to do this. Fine, I'll do it. 28 times 8, let's see, it goes 8 times, 16 goes 1. Why did I say 8? 16, 17, no. Oh, 8 times 8, 64, wow, great math teacher. 8 times 8, 64 goes 6. 8 times 2 is 16 plus 6, 224. That sounds about right. So 224, so it goes, 28 goes into 240 times, into 245 8 times. All right, and that will give you a remainder of 21 over 28. Okay, 28 goes into 245 8 times, which is 224, and then you have a leftover of 21 over 28. Okay, hopefully I'm right. King Arthur again. Yeah, this took 13/14 of his kingdom, and he wanted to break it up into little parts. Okay, so that's how much he had, and he's breaking up into 2/5 parcels. Okay, definitely not the same LCM, so same denominators. You gotta find something common. In this case, I think it's going to be the product, 90. 4 times 5 is not 90. Okay, oh, not that one. So 4 times 5 is carried 70 is your LCM. Okay, so 70 is the first number in either multiple in both times table. Okay, that is common to both. But this one's times 5, so on top times 5, so that gives you 65. 5 times 14 is 70, and then the top times 14, which is 28. This is 65. So, again, the beauty about this, you can cancel your denominators. Okay, or just throw them out. Becomes 65 over 28. Or if you simplify, change to mixed number, 28 can go into 65 2 times, which is 56. 9 left over 28. Okay, that was simple enough. Okay, so we have two more, sorry. Ooh, 15 minutes already. No, yes, 4.5 laps around the high school track equals 1 mile. Jane ran 30, so Jane ran a lot. So she ran 30 and 4/5 laps. She's trying to figure out how many miles that equals to. Well, she knows that if she runs 4.5 laps, that's 1 mile. How many miles did she run then? LCM, no. Let's change this to a mixed, improper, I'm sorry. 5 times 30 is 150, plus 4 is 154. Over 5. On the other side, you get 2, 4, 8, 9 over 2. LCM is 10. Right? The LCM of 5 and 2 is 10. So this was times 5. Top is times 5, which is 45. 5 times 2 is 10. So that gives you 154 times 2 is 308. So we're asking ourselves how many times can 45 go into 308, and let's write it as a fraction first. So it's 40. Let's see, 90, 180, 270 plus 45 equals 5. That'd be too much. So again, it's 1, 2, 3, 4, 5, 6 times, and 308 minus 270 is 0. 10 minus 3, 8. 38. 38 left over 45. Okay, so 45 goes into 308 6 times. 38 left over 45. If I'm not mistaken, I might be. So that's it. And then last question. Okay, so this just once you understand how to set up, how to write the number sentence, you understand the situations correctly, so that you put the sentence in the correct order. Everything else is just repetition. Okay, the algorithm that repeats over and over again. Clear annotations, there we go. And we have one more, 2 and 3/7. 2 and 3/7 divided by 5 and 1/3. Here we go. So again, change this mix into improper. 7 times 2, and then a plus here is 14. 17 over 7 divided by times and plus. 3 times 5 is 15. 16 over 3. Can't divide it yet because they're different denominators. Change it to 21, both of them. This is times 3, and then times 3, which is 51, I think. 21, and then here is times 7. It's going to be times 7. This is 4. Carry the 4. 112. We can cancel the denominators because all the sizes are of the same. They're cut into 21ths. Okay, so essentially we're asking how many times can 112 go into 51. So it's 112 over 51 over 112, sorry. And 6, can we divide this by, no, I don't think there's a common, can I simplify anymore? No. Okay, that's it. Sorry, that's it. If any questions, email. If I can get back to you, I will. And, oh, there is no magic word, secret word, or anything. Here is what you'll do tomorrow for the extra 2 points so that I know you paid attention to the past 19 minutes of this video. Here, you will do this. You will wear mixed, is it miss? No. Mixed socks, yes. Mismatched socks. That's what I meant to say, not mixed. Mismatched socks. What does that mean? If one is red, the other one should not be red. So they should not be matching socks. They should be mismatched socks. Okay? One of one color and the other one of another color. Okay? That's it. And obviously I can't shut this off like the other video. Maybe. Okay, so you can shut it off, but I can just hang How do we? Oh, there we go.